Physical weathering is the breakdown of rock without chemical change. I like to look at it like this in my own mind. If you took a piece of chalk and you broke it into two pieces, they are both chemically exactly the same thing. What's happened is you have made two smaller pieces of chalk. When you have chemical weathering, there is a brand new product on the other end of the chemical weathering. For example, a stalactite or a stalagmite. Those weren't there before. Rust, that wasn't there before. With physical weathering, we're just taking the rock and breaking it down into smaller pieces. For our purposes, there are going to be three types of physical weathering. Those three types are frost wedging, exfoliation, and organic wedging. Look at that bottle. I know you've seen something like this before. You've probably done it. Frost wedging is the breakup of rock due to the expansion of freezing water in cracks or crevices in the rock. We call these cracks or crevices joints. These are fractures in the rock that serve to increase the surface area of the rock, and as a result of that, the exposure to the atmosphere and water, which accelerates degradation. Once you break the rock down through frost wedging, it will fall and then accumulate at the base of a cliff. That material that accumulates at the base of the cliff is called talus, or if it's shaped in a conical way, a talus cone. This is the accumulation of rock debris that's found at the base of a cliff where physical weathering has occurred. Water, as you're probably aware, expands when it freezes by about 9%. This is why an iceberg floats, because it's less dense than liquid water. You probably have taken some sort of beverage, for me it was probably a beer, on a warm day, stuck it in the freezer, and forgot about it. Opened the freezer the next day, and what happened? Exactly what you see happening to that bottle of water. Well, this in a way is the way frost wedging operates. If you take a look at this rock, this is solid granite. We can see those cracks in the rock. Those are joints. What then happens is water, either through rain or melted snow or some other precipitation or perhaps even dew, drips down into the joints, especially during the day. At night, the temperatures drop below freezing up in the mountains, which causes the water to freeze and expand. That expansion exerts force and pressure on the cracks, the joints that are in the rocks, and eventually it causes the rock to fracture and then tumble down. What you see in the foreground, all of this accumulation of rock debris, that's known as talus. What's its point of origination? Well, look up at the cliff above you. You can see along the ridge, you can see that the rock is all broken up along the ridge. This is as a result of frost wedging. The second type of physical weathering, for our purposes at least, is called exfoliation. Exfoliation is the progressive breaking off of concentric slabs of rock due to a lessening of weight from above. The Sierra Nevada is a great place to look at this because the Sierra Nevada, as you know, is a batholith. I told you that before. Batholith, remember, is this huge amount of magma that cooled below the surface and solidified into igneous rock. There was rock over the top of it, but as a result of that normal fault line on the eastern slope of Sierra Nevada, it slowly got uplifted. As it did, the rock that was above that granitic batholith eroded off. It actually filled in the Central Valley of California, the San Joaquin and Sacramento valleys. But that exposed the batholith. And it's a little bit like this. If you had a sponge on a table and you push down on the sponge, and then you took your hand off the sponge is going to spring back up. Well, your hand is all of these layers of rock that were over the top of the Sierra Nevada granitic batholith at one point. They were eroded off, and the Sierra Nevada, as a result of that, is expanding outwards. As it does, it kind of peels like an onion, like Shrek. Shrek, remember Shrek? He's like an onion. Ogres are like onions. They have layers. And if you take a look at that rock, you can see that. This is in Yosemite National Park, but you can see that the rock over on the left-hand side and over on the right-hand side in the middle is peeling, kind of like an onion. That's exfoliation. It's because of that decreasing weight from above, it allows the rock to expand outwards. And of course, when the rock crumbles and falls, as it breaks all the way through, it creates talus at the base of the cliff as well. This is a road cut in Yosemite, and you can see clearly granite does not form in layers. That's not what it does. Granite doesn't form in strata. But if you look at this, you can see it's peeling like an onion because it's expanding outwards, as it's doing here as well. That's exfoliation. For our purposes, the last of the physical weathering is organic wedging. This is the breakdown of rock through the actions of plants and animals. This could be a gopher digging in your backyard, human beings plowing off the top of a hill to make a flat area for housing, or it could be, if you take a close look at this rock, look at that. The tree is attacking the rock. It's attacking it. Can you see the branch or the root or whatever it is inside the rock? As it expands outwards, it causes the rock to crack, fracture, and break apart.